Well, here we are again, and we're still doing types of chemical reactions. This time, the type of chemical reaction involves a single replacement. That's where one element replaces another out of a compound. It's the main reaction. And I have here for my reactants, I have HClAQ. You know what that is? The name for that is, yeah, you knew, hydrochloric acid solution. Oh, you may have forgot the solution, but AQ means dissolved in water. And then this is Zn, which you know as zinc. So I'm going to put those two together, and we're going to see what happens. So let me do that right now. I'm going to take some pieces of zinc. Okay, pieces of zinc into the test tube. You might notice in the background that I have the master teacher's picture back there. Jesus Christ is a master teacher. And as a matter of fact, when he walked the earth, he was called Rabbi, which means teacher. I aspire to be like him, although I'm really a very poor copy. Okay, so I've got some zinc here. Now I'm going to add some hydrochloric acid. And there we go. Boy, it got all black in there. Well, I wish it wasn't black, but it's black. Okay. I tell you what we do have going in here, though, is, I don't know if you can see this or not, but it's just bubbling, bubbling, bubbling. That means a gas is being produced. Okay, and that gas, we're going to find out what that is by doing the tests that we did before, an oxygen test and a hydrogen test. Okay, so I'm going to set this on here. And this time I'm going to collect the gas by putting an upside down test tube over the top of this one. Okay, now I'm going to need a source of fire. So again, we're going to start this combustion reaction where we have natural gas, which is mostly methane, and mixing with oxygen. Of course, just mixing with oxygen is nothing. I got to add the activation energy. Here we go, activation energy. Flame on. There it goes. Okay. Okay, don't get too close to the master teacher there. Okay, gotcha. So I've got my flame. Let me test this gas here. Okay, first I'll test for oxygen. You know what I'm going to do is I'm going to get a second test tube just in case I want to run this test twice. I'll put that one right there, and I'm going to turn this one upside down over here like that. Okay, got it. Now first I'm going to test for oxygen, which is of course a glowing splint. I put the glowing splint in there, and I don't know if you saw it, but it just went out. It didn't reignite. Means oxygen's not present. Now I'm going to test for hydrogen. That's a flaming splint. And let's see what happens here. Ooh, there's that barking pop. That is positive test for oxygen. Let's repeat that again. First, we'll try glowing splint, test for oxygen. Oh, just went out. Probably went out because, why do you think it went out? Well, hydrogen puts out fires if it doesn't have any oxygen with it. Okay, so now we try the flaming splint. There we go. And there we got that squeaky pop again. So that's a positive test for hydrogen. So yeah, we could generate a little bit more hydrogen, catch that hydrogen there. So that's basically the lab. Wasn't very complicated, was it? But I'll tell you what, let's discuss the reaction. Okay, so here we have a combustion reaction. Methane and oxygen are combining to make two products. And here we have a single replacement reaction. We have hydrochloric acid solution with zinc metal, and we know one of the products is hydrogen gas. We established that. The other product is not oxygen gas. We know that. Is there another product? And you should be saying, yeah, of course. Matter cannot be destroyed, so the zinc and the chlorine are going to go somewhere. A good guess is they went together. Zinc chloride. So, now, but where would the zinc chloride be? Well, the zinc chloride is like the sodium chloride would be if it was there. It's dissolved in the water. So the zinc chloride is present in the water that's in the solution at the end. And how could we see that zinc chloride if we wanted to see it? Well, same way we could see salt. that's in salt water if we want to see it. We'd have to evaporate the water. Okay, so anyway, that you could write the equation and balance it now pretty easily. But also you could write the equation for another reaction. This reaction here. This reaction when the hydrogen burns. Here we go. You could write the equation for that too. Hydrogen is combining with, well, you got to have oxygen to burn. Oxygen's in the air. Did it need activation energy? Yes, it did. And what do you think's produced when you burn hydrogen? Well, hydrogen oxide. You know the formula for that? Write the balanced chemical equation. I made water. How about that? Now, of course, what state of matter was the water in? Do you see any rain coming out of the tube? And it wasn't liquid, was it? Okay, so we have, oh wait, we've got one more observation left. Whoa, that is hot. This is an exothermic reaction. And was this endo or exothermic? Well, you ask the people on the Hindenburg, and they would have no question. This is exothermic too. So, with that, we end our little session. I hope you can write the equations and get a perfect score on the quiz.